Okay, after 60 questions, I think we have become aware of some of the important concepts of the carbohydrates, and you have got a lot of medical applications of this. So let us look into some more questions there. You get an idea of how much important the carbohydrates are and how much they are useful in many biological functions. Okay, for example, alpha D glucouronic acid is present in hyaluronic acid, chondroitin sulfate, heparin. Okay, heparin, you must know some of the terms, and even though it may not be in syllabus, but it is very essential. Heparin is, this is the right answer there. Heparin is an anticoagulant. Anticoagulant means that which thickens the blood. Okay, blood thickening. Anticoagulant, blood thinning. You know the dangers associated with thickening of the blood. It may block several arteries and veins, and that is going to affect the blood flow. That results in stroke and several other ailments there. So vitamin K is one of the source which is also uh, anticoagulant, vitamin K, but it helps in formation of this. So hyaluronic acid is also another example which is found in the uh, skin, and this is also a kind of formula. For example, C10H7, something like OC10H12 or 7, something like this. Okay, but this is present in this one. So this glucouronic acid is having a hexahydric structure with some of them having OH there and here. Okay, some slight derivatives, but very good functions. Okay, and then the next question number 62. Fructose is present in hydrolysate. Hydrolysate means a hydrolysis product. Hydrolyzed product. Okay, it is present in both sucrose and inulin. Therefore, the right answer is C. C is the right answer there. So, fructose is found in most fruits, and therefore it is found in sucrose and other inulin. Is another polymer of carbohydrates, which is not there in syllabus. Yogurt, sucrose, maltose, and lactose only. And this is also a kind which is very essential. Okay, the 63. Carbohydrate found in DNA. I think you can answer this very easily. I think we have seen RNA as being found in having ribose, and DNA being found in this. D stands for deoxyribose. Okay, so it is not found in ribose, so the B is the right answer there. 64. Ribulose is a ketopentose. Is a ketopentose. So the right answer is C. 65. A carbohydrate commonly known as dextrose. Very easy. D glucose is dextrose. D actually stands for this dextrose only. Okay. So dextrin, D fructose is misnomer. It's not right. So glycogen, all these are different derivatives. So they are very closely related. You must be very careful which terms you are using. And then we have question number 66. A carbohydrate found in milk. Very easy. So it is lactose. Lactose is having some kind of structure like this. So this is all carbohydrates only. So you can see that carbohydrate which you can take can be converted into a carbohydrate can be converted into milk, or a milk which is taken can be converted into carbohydrates. So therefore you must have proper enzymes for all these interconversions. Okay, therefore children are bestowed with very good enzyme in the milk which converts it into carbohydrates or starch and sufficient amount of energy. But as we grow up, this goes back, and we are bestowed with very good uh, hydrolyzing capacity of carbohydrate in the form of bile acid or bilirubin or even some carbohydrate digester enzymes are there. Okay, a carbohydrate commonly known as an invert sugar. What is invert sugar? The word, when you get invert, you should know that it is something like a inversion. It's a product due to inversion. So invert sugar is sucrose is known as the invert sugar. Sucrose is known as the invert sugar. So sucrose is a polymer. Already we know that sucrose is a polymer. So it is found in sucrose is actually called as the invert sugar. Okay. So the next question is 68. A heteropolysaccharide among the following. Heteropolysaccharide means something which is foreign. Homopoly, opposite of the homopolysaccharide, in which you don't have any other constituents. For example, heparin is having a heteropolysaccharides. Heparin is heteropolysaccharides. Why? The reason is it is having a structure. I think probably C12H19NO20S3. It's having a SO3OH NHSO3OH kind of structure. This kind is linked to one of the C5 atom of the carbohydrate. So these N and S, there are the heteroatoms there. So heparin is, I think we have seen this as heparin as an anticoagulant. It's very useful. It comes in the form of medicine also nowadays. And has got a structure like this, NH3SO3AH. And this is the heteromolecule. In the place of COH in the fifth carbon atom, this is substituted by this one. Okay. The predominant form of glucose in solution is, this is a syllabus related question. Can you answer that? Predominant form of glucose in solution. When you dissolve this glucose, it doesn't open up. Acyclic form is open chain. Okay. Hydrated acyclic means OH with open chain. It is also not there. OH is high, it's weird. So these two are not there. So you are left with pyranones and furanose form. I think we told you about this. Pyran is having a structure like this, and furan is having a structure like this one. 5-member ring, 6-member ring. So glucopyranose is the right answer for predominant form of glucose in solution. Glucopyranose is the right answer. Okay, next 70. An L isomer of monosaccharide found in human body. L isomer of a monosaccharides. Remember, this is not a disaccharide, it's a monosaccharides only. Fructose is not found, it is supplied from outside source. And this is also supplied from outside. So xylulose is the right answer there. Monosaccharide formed in the human body. Not necessary, you must know some of the terms. The more you know now, the more it is easier for you to understand things. Now this is a very essential part of in the carbohydrates. Question number 71. Hyaluronic acid is found in joints. It's a kind of fluid, hyaluronic acid. It's a kind of fluid, white fluid. It's a kind of white fluid which acts as a lubricant. Okay, if this you can see that starch can act as a lubricant. Starch, gum, starch paste are all prepared. Gum paste is also. So this hyaluronic acid is a derivative of carbohydrate which acts as a lubricant, and that helps in free movement of joints. So as you grow older, this fluid leaks and it increases the friction. There is no free movement, therefore it's present only in the joints. It's not present in the brain, not in the abdomen, and not in the mouth. So as you age, the hyaluronic acid goes off and friction increases, therefore you get the joint pain. Joint pain is very common nowadays because for the old age persons, and the reason is the absence of the hyaluronic acid. The carbon atom which becomes asymmetric. Remember this. This is asymmetric. So C star is what is when the straight chain of monosaccharide changes to into ring form is known as, I think we have seen this, anomeric carbon. So I told you that if you have CHO like this, you are converting it into CHOH. So in one you have CHOH like this, in the other you will have OH in this side. Therefore, you have OH in the right side, OH on the left side. Therefore, this carbon atom is anomeric in nature. Anomeric in nature. This is also anomeric in nature. Okay. Epimers, it may be any isomer that will be, we call it as the N-isomer. But only one carbon atom having two different isomers responsible for two different isomers during the preparation and during synthesis, and during this particular property of in which you get the straight chain is converted into ring. A very important question for you. Straight chain to ring is known as the anomeric carbon. As well, so none of this is also the option there, but you have A as the right answer. Okay. The smallest monosaccharide having furanous ring structure. Any idea about this? Erythrose, ribose, glucose, and fructose. B is the right answer. So this is not there in your syllabus, but remember, ribonucleic acid and ribose is there. Erythrose, uh, it's also a kind of carbohydrate. I'll just pause it. So ribose is having a structure like this. So this is the structure of the ribose. So smallest unit, and the formula comes like the C5H10O5. So this is the smallest monosaccharide having a furanous ring. Furanous is, I think, a 5-membered ring structure is known as the ribose, and it's a kind of aldopentose when you have a open chain structure for this. Which of the following is an epimeric pair? Question 74. Epimers only change in, this is the change in functional group. Change in functional group. How? It changes from aldehyde to ketone. So here this is change only OH on the left side to OH on the right side. So that is an epimer. Okay. Galactose and mannose, number of carbon atoms. Lactose chain linkages, chain linkage and polymers. These are the polymers. So the right answer is glucose and galactose. That one is called as a epimeric pair. This is a functional pair, and this is a another isomer, just an isomer. This is also another polymer isomer. Okay. So the next question is 75. Alpha glycosidic bond. I think alpha glycosidic bond. We have often seen alpha and beta glycosidic bond often is present in maltose. So we already seen this. It's the bond that we have seen like this. This is one chain, and this will be another chain, carbohydrate chain. In the beta, you can find this beta galactose in the lactose, but in the maltose it is just alpha glycosidic is present in the maltose. Next question number 76. Branching occurs in glycogen approximately after every 10 glucose units. Glycogen you must know, but this is not there in your syllabus. But remember, 10 glucose units. So there is branching means it goes like this, 2, 3, 4, 5. So after that there will be some branching in this side. So that is what is here also there will be branching. So that is for 10 glucose units for the glycogen there. N-acetylglucosamine is not there in your syllabus, but just remember it. N-acetylglucosamine is present in hyaluronic acid. Remember, uh, this is the liquid that I have told you is very essential, present in all joints. Present in all joints for free movement. Okay. Now this is a very important question. That question number 78. Iodine gives a red color. You have done the starch iodine complex in the lab, so which is violet in color because of the formation of some kind of complex there with carbohydrate. So starch and iodine will give you the violet or purple or dark blue color. But this red color is given by the glycogen only. So C is the right answer there. Glycogen is another isomer of that. Next question 79. Amylose is a constituent of starch. Very important question. Yeah, you have seen the starch and amylopectin, amylose are all those are present only in the starch only. It's not there in cellulose and glucose, and none of this is there. The last one for today is the synovial liquid. Synovial liquid, I think, is the these joints, where movement is required. Movement of the joints is required. So synovial fluid contains, I think we have already seen this many times, but in a different form. It is hyaluronic acid. It is hyaluronic acid, not heparin. Heparin is anticoagulant. Chondroitin, keratin are different types of protein. So this is a keratin present in hair and nails. Okay. So hyaluronic acid is very essential. It's unfortunately not there in your syllabus, but we have learned a few terms in applied carbohydrate chemistry, like for example, synovial fluid, heparin, hyaluronic acid, the formation of the complex, and other essential things connected with this. Okay, so I stop with today's section and see you soon.